Welcome to the DIY Honda Garage channel. In this presentation, we will delve into the diagnostic trouble codes DTC U0100 and U0122, which indicate communication issues between various control units in the Honda CRV from 2017 to 2022. Specifically, DTC U0100 refers to the power control unit losing communication with the powertrain control module, PCM, while DTC U0122 indicates that the power control unit has lost communication with the anti-lock braking system, ABS, and vehicle stability assist, VSA modulator control unit. Understanding these codes is critical for diagnosing and resolving communication failures effectively. We will explore the affected components, potential causes, and symptoms associated with these codes. Additionally, practical troubleshooting steps will be outlined to assist technicians in diagnosing and rectifying these issues within the vehicle system. DTC U0100 indicates a communication failure between the power control unit and the powertrain control module, PCM. The PCM, located in the engine bay, manages critical engine functions. DTC U0122 highlights a similar communication failure between the power control unit and the ABS VSA modulator control unit, which are vital for maintaining vehicle stability and braking efficiency. This modulator unit is typically situated underneath the vehicle. The power control unit acts as a hub that manages communications between these systems, and any failure in this unit can lead to the DTCs being triggered. Identifying these components and their locations is essential for efficient troubleshooting. There are several possible causes for the DTCs U0100 and U0122. Grounding failures can disrupt the electrical circuits necessary for communication between control units. Power source failures can also lead to communication breakdowns, as the systems require stable voltage to function. It's important to inspect connectors for damage and ensure all terminals are securely attached, as connector issues or loose terminals can interrupt communication. Intermittent faults may occur sporadically, complicating diagnosis, so it's crucial to conduct a thorough examination of the vehicle's wiring and connections to identify the root cause effectively. Symptoms associated with DTC U0100 and U0122 may include warning lights appearing on the dashboard, indicating potential malfunctions. You may notice reduced engine performance, as the PCM's inability to communicate could hinder engine efficiency. The ABS VSA system might also malfunction, affecting vehicle stability and safety. Some control units may be unresponsive, leading to frustrating experiences for drivers. Furthermore, sporadic system resets may occur, complicating driving conditions. Recognizing these symptoms early can significantly aid in the timely resolution of the underlying issues. The first step in troubleshooting DTC U0100 and U0122 involves clearing the DTCs using the Honda Diagnostic System, HDS. Start by switching the vehicle to off or lock mode. Following this, turn the vehicle back on and allow it to sit for at least 6 seconds. During this time, electronic systems are initialized, allowing for potential resets. After waiting, check for any DTCs once again using the HDS. This step is crucial to ascertain if the errors are persistent or possibly intermittent. Addressing intermittent issues may require additional testing. Once the DTCs have been cleared and checked, the next step is to turn the vehicle to on mode without starting the engine. Use the HDS to check for any controller area network, CAN system, DTCs. This system connects multiple control units in the vehicle and is crucial for proper functionality. Note any indicated DTCs, as they will direct you to the next phase of troubleshooting. Depending on the diagnostics results, It's essential to follow the system's recommended procedures for addressing the specific issues identified. Recording these findings will aid in the documentation and future reference. For the third troubleshooting step, select the function test option in the HDS and choose the FCAN bus connected unit check. Here you will determine whether bus A is available for communication. If bus A is not available, further checks are needed. If it is available, proceed to check bus B's functionality. This step will help identify whether the FCAN, Flexible Controller Area Network, is operational and whether it has detected the connected unit properly. Knowing the status of these buses is critical for pinpointing communication errors in the system. In this step, you will conduct an open wire check on FCAN A lines. Start by turning the vehicle off and disconnecting the connectors from the CAN gateway and the body control module. Measure the resistance between specified test points. For effective results, ensure the vehicle remains in off or lock mode during this process. The aim here is to assess the integrity of the B-CAN wires responsible for communication. If the resistance is greater than 1.0 ohm, you will need to repair the open wiring to ensure proper functionality, as higher resistance could disrupt communication signals. For the fifth troubleshooting step, again utilize the function test option in the HDS and reselect the FCAN bus connected unit check. Based on the latest detected DTC, ensure that the transmitting control unit is correctly recognizing the CAN gateway bus channels A and B. This assessment is vital for determining whether the transmission of data is functioning correctly. If the unit detects the channels normally, you can classify the failure as intermittent, indicating that the system appears to be operational at that moment. However, continued issues may warrant further exploration of the connections, particularly focusing on the transmitting control unit and the CAN gateway. In this step, turn the vehicle to off mode before jumping the SCS, short circuit simultaneous, line with the HDS. This process stabilizes the diagnostic system for the following tests. Disconnect the appropriate transmitting unit connectors based on the indicated DTC before measuring the resistance between the specified points. The goal is to verify the integrity of the FCAN AH and AL wires. If you find that the resistance is 1.0 ohm or less, the wiring is intact, and you may need to replace the corresponding control unit. Conversely, if resistance exceeds this threshold, repair the damaged wiring to restore functionality. Following similar procedures as before, start by switching the vehicle to off mode and use the HDS to jump the SCS line. Next, disconnect the specified connectors for the transmitting control unit related to the detected DTC. Once disconnected, measure the resistance across the defined points. Verifying the resistance here is essential, as it will indicate whether the FCAN BH and BL wires are clear of faults. Should the resistance register 1.0 ohm or less, the wires are likely in good condition, and replacement of the control unit may be warranted. A higher resistance indicates an open socket, necessitating further repairs. The final step requires you to turn the vehicle off, then disconnect the body control module connector. Next, jump the SCS line with the HDS, as performed in previous tests. This action helps prepare the system for a comprehensive check of communication lines. Disconnect the relevant control unit connectors, as indicated by the DTC displayed earlier. Measure the resistance in both the FCAN H and FCAN L wires. A nominal reading of 1.0 ohm or less indicates that the circuits are operative. If resistance is above this threshold, it will be necessary to repair any shorts in the lines to re-establish effective communication. After completing the necessary repairs and checks, Reconnect all affected connectors securely. Follow this by clearing all DTCs using the HDS to reset the vehicle's communication systems. It's essential to take the vehicle for a test drive, observing its performance and ensuring no DTCs reappear during operation. Keeping close attention to any warning lights or abnormal behavior is crucial during this validation step. Confirming that the systems are functioning correctly without triggering new error codes will ensure a successful repair. Proper documentation of the steps taken should be maintained for future reference. To prevent future occurrences of DTCs U0100 and U0122, regular maintenance and inspections are critical. Begin with routine checks of the wiring harness for any signs of wear, corrosion, or damage that could interrupt communications. Check all connectors for signs of loosening or damage, as they are pivotal in maintaining connectivity within various control units. Additionally, maintaining the health of the vehicle's battery can significantly affect the power source for these control units. Monitoring the functioning of electronic systems and conducting timely software updates will also contribute to enhanced performance and reduced risk of communication failures in the future. In conclusion, understanding the significance of DTCs U0100 and U0122 is essential for effective vehicle maintenance and repair. By following a systematic troubleshooting approach, technicians can accurately diagnose and resolve communication issues between control units. Regular maintenance practices, such as inspecting wiring, checking connectors, and ensuring battery health, will go a long way in preventing these trouble codes from reappearing. Thorough documentation of each step taken not only aids in the current diagnosis, but also serves as a valuable resource for future reference. Ultimately, these practices ensure the reliability and safety of the Honda CRV, keeping it in optimal working condition. Please like and subscribe to the channel. See you next time.